Cram here again. A little sick sounding Mr. Cram, so bear with me if hopefully I'm speaking loud enough for you. So how about this situation? We have a baker and they're going to make some vanilla icing from scratch. The recipe that they're reading says they want 1 cup of vanilla extract, but the label on the bottle says 2 FLOZ. So you're probably used to looking at bottles with labels with numbers and units like this. So FLOZ is fluid ounces. It also has 60 mils or milliliters there. But the question here is, you know, if the recipe is asking for 1 cup of this extract, but the label says 2 fluid ounces on it, is 1 bottle enough? Really, what that question is 1 cup equal to 2 fluid ounces? And unless you know how to do conversion factors, you're probably not sure how to answer that question. Alright, here's another more fun one. I'm sure most of you have seen this and thought about this, maybe not. But how much water is used every time you flush? And I know all the boys and men out there, you probably have at one time looked at a urinal, and I think this is awesome because when you look at most urinals, they actually have this label on them where it says 6.0 LPF or /1.6 GPF. And different toilets or urinals are different. They don't always have the same numbers. But that's liters per flush and gallons per flush. So I love that they do these conversions here for you where they're telling you how many liters are in a flush and how many gallons are in a flush. So what we can do with that information is we can say, oh, okay, well 6.0 liters must be equal or equivalent to 1.6 gallons. And that's really important. So you've always had that kind of equivalency or conversion factor on your toilet. You just probably didn't recognize it. All right, so just for a little bit of a comparison too, on average you use almost 19 gallons of water daily when you flush, depending on how many times you go, but the average amount. So I have 19 gallons of milk here for a visual comparison. That's a lot, right? Okay, so why is this important? How many times have you ever wanted to convert one unit to another? You probably have done this now thinking about it. We do this a lot in our culture. One common thing is, especially if you're traveling, is converting money from dollars into pesos or dollars into euros or some other currency. Often in chemistry we'll have tools where we'll be measuring in one unit, but we need to convert those measurement units into another one. Okay, and so you can kind of think of this as an adapter, a tool set that can convert between lots of different types of tools, all to have one purpose. So if you see these images here, these are all different plug outlets around the world. So Italian, France and German, UK, United Kingdom, China. So they have all these different outlets, but there is a device called a universal adapter where you can plug in your cord from any of these countries and then still have the correct plug into the wall depending on what country you're in. So that's how you kind of can think about conversion vectors in the math that we're going to work on. Alright, so the first step here is creating equivalences. And whenever you hear the word equivalence, what we're saying is two things that are equal in quantity to each other. So for example, 1 day is equal to 24 hours. I'm sure most of you know that. I'm going to use this symbology a lot, and I call it a domino. Okay, if you ever played dominoes, you have these little tiles where there's some dots on the top and dots on the bottom. So we have a top and a bottom for all of these dominoes. We have 1 day on the top of this one and 24 hours on the bottom. Another one is 12 donuts is equal to 1 dozen donuts. So there we just use the word dozen to replace a number. But we have an equivalency of 12 donuts is equivalent to 1 dozen donuts. There's your domino. We can do a cool thing with dominoes, if you ever played, is you can flip those dominoes where the bottom actually becomes the top. And that is totally cool. That rule applies here depending on how you want to use the domino for your math. Alright, so let's see how this actually works. So we're going to do a single step conversion here with some dominoes. So the question is, how many years is 925 days? Okay, we can do some simple math for this. There's several steps. I'm going to give you 4 steps to apply. This one's going to seem kind of easy, but when we get to multi-step problems, you'll want to use these 4 steps. So step 1 is to identify the starting domino. What do I start with? What's my first piece? Well, we're going to start with that 925 days. That's the only information really that I'm given in this problem to start with. So this domino has one top, no bottom. Okay, and I'm always going to draw this out in domino form. So I got a top here. Your first domino, excuse me, will always have just a top, no bottom. All right, fair enough. So here's the same question. Step 2, we're going to create an equivalence for the units. So we know by prior knowledge, probably, we've memorized this, that 1 year is 365 days. So I'm just going to draw that out in domino form. There it is, 1 year over 365. So I could have flipped it and had 365 days over 1 year on top. It just depends on how you want to use it. So the real question you want to write or ask yourself here is, can I get rid of the bottom term? How do I get rid of the days? How am I going to cancel that and be left with years? Because that's really what the question is asking about. How many years, right? Okay, so step 3 then, how many years is 925 days? So we're going to arrange the dominoes to cancel the starting term. So I write down my starting term. I got 925 days. That was the first domino that I made. I'm going to multiply that. That's what the X here means. This means multiply. By my equivalence of 1 year is 365 days. Now notice I put the days on the bottom, right? Well, there's a reason for that. I can cancel the units of days when they are diagonal to each other. So the only time you can cancel or get rid of a unit is by canceling them when they are aligning them on a diagonal. You can also go from bottom to top. I almost always do just top to bottom because that's how I do the same routine over and over. So now we're just going to do the math for this. So here's the setup again that I just set up in step 3, and now I'm going to do the math. So the math simply just becomes, all right, what are my numbers? It's going to be 925 multiplied by 1, so everything across the top gets multiplied. And then I'm going to divide it by whatever's in the bottom terms, which is just 365 here. So really this becomes 925 divided by 365, which is equal to 2.53 years. And there you go. There's your final answer. Make sure you box it so that you are identifying that that is your final answer. Pretty simple one. Let's do a multi-step one so you can see how this works with multiple dominoes. Okay, so here's the question. How old are you in seconds? All right, I'll use me as an example. So step 1, identify the starting domino. I'm 31 years old. So here's my starting domino. 31 years on top, nothing on the bottom. Step 2, create the equivalences. All right, so I'm going to start with years, and I can go logically in my head to days, right? We were pretty familiar with that. So here's my first domino that I might use, 1 year to 365 days. All right, that still doesn't get me to the answer because the answer wants seconds, right? So, all right, I'm in days. What other time unit do I know? Okay, how about hours? Yeah, okay, 1 day is 24 hours. That's easy, right? So there's another equivalence domino. So I've gone from years to days. Now I'm in hours. Still not seconds yet. Now I can go to minutes. 1 hour is 60 minutes. And then finally I can get into seconds because I know 1 minute is 60 seconds. So I'm going to use 4 different dominoes here, really 5 because I'm going to start out with my age domino, my starting domino. So now we set up the dominoes, and this step again is not about doing the math yet. It's just a setup. We want to cancel units, and that's the main goal here, and then we'll do the math. So 31 years is my starting domino. Remember, it's just got a top. I'm going to multiply that by 365 days over 1 year. I'm going to multiply that by 24 hours over 1 day, and then 60 minutes per hour, and finally 60 seconds per minute. Notice my units are canceling diagonally as I go across here, and my final units are always going to be whatever I'm trying to solve for here. Whoa, let's do that a little bit better. I want my answer in seconds, right? That's what the question is. How old are you in seconds? So the final domino, it has to have whatever units you want on the top. That way it's telling you, okay, you got rid of all of these units. Okay, you're converting the units into seconds. See how that works? All right, so now we do the math. And our math is set up here. So I'm just going to multiply everything across the top. 31 times 365 times 24 times 60 times 60. And then I'm going to divide by everything multiplied across the bottom. So it's 1 times 1 times 1 times 1, which is just 1. and we get 9.8 times 10 to the 8th seconds old. So I notice I wrote this in scientific notation. I have 2 sig figs because my number here has 2 sig figs. The ones are called absolute numbers, so we don't really count them towards sig figs. But my smallest number of sig figs is 2 here. So that's what my answer should have. And make sure to box your answer. Alright, so what should you have learned? You should have learned the importance of unit conversions in science. You'll do this a lot. How to create domino equivalences. You'll always have a top or a bottom, except for your starting domino. We'll just have a top. And then how do you use the domino method for dimensional analysis? That's really what we're doing here. To cancel units and convert from one unit to another. Thanks a lot, guys.